Hello, and welcome to this webinar on spending less time in spreadsheets by using SQL. So by the end of this session, my goal is that you will have a sense of ways in which you can optimize your workflow, automate some repetitive tasks, overall improve the quality and accuracy of your work by spending more time in SQL. So here's a brief overview of the topics that we're going to be covering in this webinar. So first, we're going to spend some time talking about things that are beyond spreadsheets. So some SQL commands that are equivalent to common tasks in spreadsheets like VLOOKUPs and pivot tables. And second, since we know here at DataCamp that reading SQL queries can get complex very quickly, we'll be covering some techniques to break down and read long, complex queries and understand their logic, structure, and output. And finally, we're going to very briefly discuss how you can connect to a SQL database using R or Python, since no amount of SQL knowledge will really make huge data sets easier to open and work with in spreadsheets. So I want to give you really just a sense as to where to start in terms of how to open bigger data sets in programs like R or Python. But first, a little bit about me. So my name is Mona Khalil. I'm a curriculum lead here at DataCamp, and I've been working in research, analytics, and data science for a few years now. I have experience working with data in education, marketing, and government, and overall those inform the work that I do here towards the goal of democratizing data science education that we have at DataCamp. I also recently launched my course on DataCamp, Intermediate SQL, which covers some of the material that we'll be discussing here today in much further depth. So I encourage you to check it out, and please feel free to leave some feedback and let me know what you think about the course. So before we get started, just a quick note. I will be allotting time at the end of this webinar to answer your questions. Please feel free to keep asking them throughout, and I will get to them at the end of what we're going to be covering today. So you may be wondering, what is a typical workflow between SQL and spreadsheets, and where might working in SQL have an advantage for working in a spreadsheets program? Furthermore, you may be wondering how your workflow might benefit from the information we'll be covering in this webinar. So in short, I think your workflow will benefit if it looks something like this. So if the majority of your work is done entirely on the spreadsheet side, I think that you'll gain something from learning some basic SQL queries and doing some of those tasks using SQL queries instead of working directly in spreadsheets. So you may be receiving data from disparate sources and spreadsheet files, or you may have to request it from a database administrator or downloading it from some form of data management system. In truth, if your workplace collects any kind of data, there's a good chance that your organization has a relational database and a database management system that would allow you to access that data directly instead of having somebody send it to you. So some example of those types of databases are PostgreSQL, which a lot of our DataCamp courses use PostgreSQL as our image on the course. Another example is SQLite or Oracle, but there are many others. So each one of those has an interface where you can query data from a relational database. And this is an example of what the Postgres interface looks like, called pgadmin. So here's a list of all the databases and tables available to you, as well as other information. Here's an example of where you write your SQL queries. And here's where you get the output. And if you take any of DataCamp's courses in SQL, you'll notice it's set up in a fairly similar manner. A second workflow, which I'm demonstrating is different just based on the colors that you see here in the arrows, is that you have some basic familiarity in SQL. You might know basic SQL queries like select and from and group by. And then you extract that data to then work in spreadsheets and further get it into the final form that you need for whatever task you're completing at work. So my hope here is that you'll learn a set of handy functions to move more of your work back from here over here. So why might you want to move more of your work from spreadsheets into SQL? The primary reason is it will save you a lot of time. If you're working with larger data sets, array formulas such as VLOOKUPs, as you might see in this example here, you've probably noticed that array formulas are very slow. And if you're working with maybe 10,000 or more records, your program is likely to lag and crash. So combining two different sheets or two different workbooks worth of data using a spreadsheets program has its limitations once you reach beyond a certain set of data, like the size of a set of data. The second reason is greater reproducibility. Your queries can be saved, is really just the main thing. You can save your query as a text file. You can save it within any of the SQL Studio programs, kind of like pgadmin that I showed you on the previous slide. And the closer your data table is that you export from SQL, like the closer it is to its final form, the more of it can be reproduced without additional work on your part. And the third, and I think very key reason here, is the reduction of errors. The more work that you do manually, the higher the probability for errors to occur over time. If your query is saved for future use, you simply have fewer opportunities to make mistake in your work. Okay, so it's time to jump into our first example of VLOOKUPs versus joins. So as I had mentioned on the previous slide, VLOOKUPs pretty taxing on a spreadsheet. And I'm going to be using an example here of open job listings from the nyc.gov website. So this was downloaded as a relational database with multiple tables. What you have here on the left is a table of individual job listings. So you have an ID, you have a business title, and then you have a title code, which then ties to more information in this table, which is titles, which tells you the civil service title, what the category of the job is, and some other key information that you may want to combine together to get a clear picture as to who's hiring for what, and in what categories, and possibly any other questions that help you in your day-to-day work. So if you've used VLOOKUPs, you know that there are several rules and limitations. And if you're like me, the learning curve of VLOOKUP is, oh, the lookup value on the right has to be the first column on the left. There's a lot that you need to manually edit and add in to be able to pull in all of your data. And every column that you do a VLOOKUP in just slows everything down. So there's a lot of manual work involved. And this type of, and with more than a few thousand records, you simply just risk crashing your program. But this is a task that is very easily done in SQL using a join. So what you'll notice here, this and this are the identical tables from the previous slide. And this query here combines the information that we pulled in the VLOOKUP. And I'm going to walk you through this, so don't worry about that yet. But this SQL query pulls and produces the exact same results by the information from those two tables. And having this, you can save time with this type of operation by using SQL instead of spreadsheets, especially if this is the type of task that you need to do on a regular basis. So let's talk a bit about the logical flow here. So this is the VLOOKUP formula, and this is the query that we have here. So the first task that you do in a VLOOKUP is you identify your lookup value that's on the left table. So this is what you're doing here. You're identifying the lookup value, which in this case, what I've done is I've selected several columns from tables that I'm calling J for job listing and T for titles, and then joining titles onto job listing using matching values. So I've decided my lookup value here, which is the title code column, because it was identical. If you take a look here, there's a title code and there's a title code. So these are identical columns that you can use to match just like you did in a VLOOKUP. And then for identifying the array, I've identified the table on the right. So I've selected columns from job listings, which is my table on the left joined it, which means this is the left table and this is your right table. And this right table is equivalent to the array right here. And then the final thing is you identify what columns you want to pull data from. So one key thing that you can do here, for example, in SQL, You can put the columns in any order you want. In this case, I've decided for this data set to make the most sense. I've put the 2 columns from the right table, or the search array. So in this case, it was column 2. Here, I identify the column names that I want and put it into the query. Okay, so it's time to jump into another example. And in this example, we're going to be talking a bit about pivot tables, which is an additional function in SQL that we're going to be using here. So before we move on, I do want to remind you again that I know some of you are asking questions, and I will be taking time at the end to review your questions. So another key Spreadsheets feature that can be accomplished within SQL is the pivot table. And if the information that we've covered so far about joins is familiar to you, you may have noticed that joining across tables in a database has some key limitations that prevents you from getting the data in its final format. Nearly all of these limitations can be addressed with 3 SQL functions, which is group by, where, and case statements. So the pivot table you see here does 3 tasks. This pulls data from an additional column that was in the jobs all table, the job listings table, which is the agency that's hiring. And I was curious how many open positions there were in each agency and what's the highest salary that they're offering for any of these positions. So this pivot table here does 3 key tasks. It aggregates data according to the agency. It counts the number of jobs, which is in the values section of the pivot table, and it calculates the maximum salary for any job post. And this is very easily done in SQL as well. So what you first do in SQL is you will select the column that you want to aggregate by, which is the same as the rows. You create columns that calculate the aggregate values for the information that you're interested in. Here, for example, again, we're counting the job IDs and giving it the alias number of jobs to make it more readable in the table here. And this is exactly the same thing that we did in the pivot table. And then we're calculating the maximum salary that they're willing to offer for any of these positions. And you end up with the exact same output. The one additional step that you do within SQL is you group by. So you specifically have to group by the column that you are aggregating in the rows like this, as opposed to it being done manually in a pivot table. So do you notice anything interesting about the output table? There's quite a difference in terms of the number of jobs that each of these agencies is hiring for, as well as quite a range in the maximum salary that they're willing to offer from it for any specific position. I wonder why that is. So before moving on to the next topic, I just wanted to give you a quick direct comparison as to the pivot table functions and the SQL functions. So here's a direct comparison. Information in the pivot table's rows are selected and grouped by, and this is identical to what's here. Information that's counted or anything you want to place in the valve right here, and most of the functions actually have the exact same name. So count, max, min, sum, average. They're either identical or very similar in SQL. So it's fairly easy to translate your work from queries to queries that pivot data in a database. Awesome. So the one other thing here is that if you want to include a filter, that's simply a where clause. So if I wanted to filter for only positions that were listed as full-time, which in this case, the column is FT_PT, I just put a where clause underneath the from clause and before group by, specifying what I want to look for. And this is the same as putting a filter here and checking off the individual items. Awesome. So it's time to expand on the previous example by talking about pivot tables and case statements. So the last field, columns, in a pivot table, it requires another key function in SQL to transform your data from wide into long. And I'm going to give you a basic example of a case statement here first before I show you how to turn this into columns. So case statements are very similar to the if statement in Spreadsheets. You can use it to complete tasks such as testing a logical condition or creating a category. So in this example here, what I've done is I created a new column that categorizes the level column, which as you can see here has numbers from 1 through 4, as either management or non-management. So if the level is greater than 3, I want this new value to return management, and if it's not, then I put non-management. And this is very easy to do in SQL as well. So I've set up a basic SQL query here that does the exact same thing, and I'm going to walk you through the different parts of the case statement and what it does. So I first selected every single column in this table, and that's what this star means. And then what I've written is a case when statement. So in essence, this says case when, which is the same as if, the level is greater than 3, which is the same as this condition here, then return the value management. And for everything else, return the value non-management. And then specify the word end to show that your case statement is done. And then give it a name that's human readable. Whatever your choice is here, as creates an alias. You can call this whatever is easiest for you to read and to convey what you're showing to your audience. And here's a direct comparison. If logical expression, case when, logical expression, then value if true, else value if false. And if you've used this before, you've probably seen that you can put multiple if statements inside of each other and nest them, and you can create a very complicated statement to test multiple different conditions. Instead of having to nest things and keep track of 10,000 parentheses in an if statement, you just need to put a new when clause. Case when, this and that, and then just put another when and another when, and then specify your else, and then end the statement. It's very similar. So case statements for columns. Case statement is how you also pivot data into columns. So in this example, I've added a column breakout for the full-time, part-time column, where I wanted to count the number of jobs by full-time and part-time status. And the resulting table still has agencies and rows and 2 columns breaking out the number of jobs by full-time / part-time status. So, and then it returns a count of each. So you'll notice here that a lot of these agencies do not have any part-time job listings, and some of them have quite a few. And you'll recall that earlier we used SQL to count the record of job IDs in order to get a total count of the jobs. And similar to the pivot table, you're going to break this line out into 2 separate ones to create 2 separate columns. And in order to properly count the data by full-time and part-time, you're going to turn this into 2 columns like this. And I'm going to walk you through this. In essence, let's read this statement starting from the inside. You'll notice that the case statement says case when FTPT, which means is this a full-time or a part-time position, equals F for full-time, then return the job ID. So in essence, inside here, it's bring back and return the job ID for anything that meets this condition right here. And then you can end the statement. And here it's important to note that we didn't include an else statement. That is an optional part of a case statement that if you leave it out, you will return only null values. So in essence, what you're doing here is you're counting all of the job IDs that were returned because they met this condition. And this count, you're counting the entire case statement. And then you can give it an alias of full-time or anything else that helps you convey the information that you're looking at. And then to create the next column, you're going to create a second case statement. And for as many columns as you want to create, you simply list them one after another to meet all the conditions that you're interested in. And this is what your table looks like. The results are identical, and you get the information here in the same format. And except the one thing you'll notice, instead of blanks, you're going to get zeros. So you have a count of 0 here. So where is this most useful? So this is the kind of task that's particularly useful to your workflow if you're doing the same type of thing on a regular basis. So if you have a lot of manual repeated tasks in spreadsheets that take up a lot of time, this is a great opportunity to save some time by writing queries that you can save and then reuse whenever you need to run it again. That way you have less data to manually copy paste, you have less results to calculate, and then when you present your report, all you need to do is run the same query every time you need it to quickly produce your results in their final form. The next key point here is that you're reducing errors. Simply put, the more manual work that you do in spreadsheets or any other program, you have a greater risk of errors. By setting up a query that minimizes the amount of work you need to do in SQL, you are drastically reducing the risk of creating manual errors. Your query also serves as documentation, and I think that's one thing to keep in mind here is that if you do find an error, you have a document here that you can go back to that is your SQL query and read and figure out where things went wrong instead of having to repeat your entire workflow. And finally, SQL is incredibly useful if you're interfacing with BI tools or business intelligence tools, or possibly a dashboard. So most companies' dashboards where you have like regularly refreshing tables and graphs that track performance and key metrics will likely use SQL behind the scenes. So an example being Power BI. If you were connected to a database in Power BI, you can run a SQL query, or there are likely SQL queries that run that pull the data you need in order to generate graphs in your dashboard. And knowing SQL is a great way to understand what the information is that's in these dashboards, how they're being transformed, and how you can modify it to help answer your questions on a day-to-day basis. Great, so great job so far. Before we finish up and move on to connecting within R and Python, I want to spend a bit of time just telling you some very quick tips for reading complex SQL queries. You've probably noticed that in your efforts to learn SQL, queries get long very, very quickly. The query you see here is actually an example from my course in Intermediate SQL. This has 34 lines. And if you take a look at any of these things, like if somebody else wrote a query that you're working on, this can very easily become overwhelming. This also includes 2 different subqueries and then information query. Each of these 2 that were generated. We'll walk through some parts of this, not entirely, but we're going to walk through some key parts as to how to make sense of a query like this and understand what the person who wrote this is trying to get out of the data that's available to them. So the first key step is to format your query. If somebody sends you a query that's sort of in paragraph format, is not very well organized, or is difficult to read in terms of what's trying to be done, you can copy paste the query into a SQL code formatter. And this is just an example of one that I use. If you do a quick Google search of SQL formatter, you will easily pull up 10 results, if not more. Whichever one helps you read your queries the best, you'll get very similar but slightly different results. Essentially, you paste in an input query, you hit beautify or format, and then you end up with an output query. The second step is to read the information that's furthest indented to the right. So you'll notice that with SQL, we start with a select statement, the columns underneath are indented, and then there's more and more information that's even further indented. So in this example, there's a select statement inside this other select statement, which is called a subquery. If you're interested in learning more about subqueries, I do cover them in my course. In essence, it's like an intermediary table. And anything that, once it's been formatted, is indented further to the right, this means it's being processed first. So you're selecting information from something you're selecting first as a table you're using to then transform some information into a main query. And in this second example, you'll notice what's actually indented here is the case statement. So this tells you that all of this information is part of the same case statement, and the outcome creates one single column. The third step is to read information that's in the parentheses. So starting from the furthest indented, just like in step 2. So there are a handful of different, there are 2 sets of parentheses here, and we're going to start with what's most inside. So this is within parentheses, and it tells you that these 2 are being added together to create a new column that's called total. And in this example, it's goals. So the database that's being used here is about soccer matches, but this could be anything. It could be base price plus taxes. You can add information from 2 columns in the same way that you would in a spreadsheets program. And then this tells you that these 2 are part of one unit that generates a new column. Second, you'll notice the entire select statement that's inside parentheses here. And this is what we call the subquery that I talked about on the previous slide, which is sort of an interim table. So the information that's in here will be processed once you've read everything that's already indented, because that tells you this is a unit of either information or calculation, very similar to what you would do within a spreadsheets context. And in this case, this is a subquery. So this is sort of an interim table that gets processed first and then moved to the outer table. And I think a clear spreadsheets example that you could think of here is, imagine the situations where you create a pivot table and then use that pivot table to then calculate something else. It's very similar to what you're doing here with a subquery. And we cover it pretty extensively in the intermediate SQL course, so I do encourage you to check that out if you'd like to learn more about how to best use subqueries. So the final step is to read information on the outside of the query, because this is the information that's going to be selected and what's going to generate the final table that you get as output. So in this case, that means there may have been 1, 2, 3, 4, 5 columns on the subquery, but the final table is only going to have 4, and it's going to filter information from this subquery. So it's going to have fewer columns and fewer rows. So that's it. That's essentially how you read complex SQL queries. And like I promised you at the beginning, I said I would cover briefly how to access a SQL database from within R or Python. So I'm going to include some very quick tips here on how to do that. So there are a number of both R and Python packages that are fantastic to work with when connecting to SQL databases. And choosing which package entirely depends on what your database looks like. But if you work at an organization that already has a relational database set up, or if you already have access to it, you should be able to connect to it in R or Python using one of these packages. So if your organization has a PostgreSQL database, you can connect to it using, say, the R PostgreSQL package, the scicopg2 package in Python. Connecting to one of these databases in each of these interfaces requires pretty much the same information you need to connect to it in an actual SQL interface. So if you'll remember the PG admin slide at the beginning, where you have an interface to interact with a relational database, in order to get access to those, you usually need a username, a password, a port number, and some other key pieces of information to connect to that database. And this is essentially the same type of information that you use to connect to your database in either one of these packages. I do suggest that you look up the specific type of database and the programming language you want to work in. So connecting Oracle database in R will get you information on how to connect using this package in R. And the same thing for Python. And finally, if you want to learn more, and if you want to take your SQL skills to the next level, I highly recommend that you check out the courses that we have available at DataCamp. We recently launched 3 new and exciting courses in SQL, and that brings our SQL library up to 5 courses, and we have several more set to launch within the next month. So I highly recommend you check these out, complete all these courses before you get a sense, before we start launching courses in the next month, so you've completed all the key prerequisites, and get prepared to learn everything about SQL, how to do reporting, how to use SQL for business, how to use SQL for data-driven decision-making, and a lot of other topics. I also recommend that you check out Data Camp Practice. We have practice questions for Introduction to SQL, as well as we're creating practice for joining data in SQL and intermediate SQL. So if you've taken these courses and you really want to test your knowledge of these concepts, this is a great way to apply them in a variety of contexts. And finally, if you're interested in learning more about accessing databases from either Python or R, we have a few courses about importing data from either of these two sources on both the Python and the R side. And then I also suggest you check out guides written on R bloggers, and there are several other similar websites that put out very clear guides on how to access databases in each of these programs. So thank you for listening to this webinar. I do want to quickly say that the data that I used was from Open Data NYC, where you can access a list of open job listings available currently, and it's kept, I believe it's refreshed on about a weekly basis, so you can access the same data too if you want to play around with it, practice with it, or with any other similar data set. There's a lot available through this source. We have a great list of questions that I think will also teach you some additional information, so I encourage you to sit tight and see what you can get from this list from the questions that everybody on this webinar has been giving us so far. And thank you very much. So the first question I'm going to answer says, Excel 2016 has many functionalities now which allow you to create power pivots, joining tables from different sources. Would this not save time as well? So yes, I think this absolutely will save time as well. I think that that also doesn't necessarily solve the problem of the limit of the data sizes that you can access within spreadsheets. Within my own workflow, a lot of times I've found that pretty much if I'm working with a data set that has more than 50 to 100,000 records, even power pivots have their limits in terms of actually working within spreadsheets, because whatever I need to do may simply crash the program. So really what you get access to in SQL is the ability to deal with a much larger volume of data. So we're talking hundreds of thousands, if not millions of records that you can process, that it takes processing time. If you run a SQL query in pgadmin on 10 million records of data, it will take a bit of time to run, but it won't crash the program. So how do you get spreadsheets into your database? That is an excellent, excellent question. We just launched a course called Intro to Relational Databases, which actually teaches you how to take a spreadsheet and turn it into a database. And I think that that will explain it better than I can in a Q&A session. But the short answer is you can create one locally. If you're working on a program like Postgres or SQLite, you can have a local copy of a database if it would be useful to you in terms of processing that information. So if somebody keeps sending you data in spreadsheets, you can put it into a relation, like you can import it into a relational database. If you know that you're going to get the same 20 columns and then a new 100 rows of data, and it always fits the same exact parameters, you can set it up as a relational database yourself to save you time over time and really just keep a record of all that database in one place instead of, say, an entirely separate spreadsheet every single week. I also got a question of, do I have to place group by before order by in SQL? And the answer is yes. Group by, the group by statement is written after from and where, and before ordering. Ordering is the last step that a SQL query will do. So we also got a question that says, what are the benefits of using Python or R to access data from a database instead of just using a SQL client to run your SQL queries? And I think the answer is, one, the size of your final form of your data and what you want to do with it. If you want to pull 5 million rows worth of data from a relational database to do some machine learning or to do some analyses. That's very difficult to do by exporting into a spreadsheets program because the file simply won't open. You can export it into a spreadsheet and then re-import it into a program like Python or R. But depending on your workflow, this may simply just save you time of having to export the data set and just connecting directly to it, allowing you to modify your queries on the fly and get your data ready for analysis in the program you're going to do your analysis in. So I got another question. Does the intermediate SQL course cover cohort analysis or other marketing research tests? The answer is no. We have a few courses in development on SQL for marketing and market research. I encourage you to take a look at DataCamp's course roadmap that's on our website, as that will give you a sense as to what is in progress. My course covers 4 key topics. The first one is case statements. The second one is simple subqueries. The third one is correlated and more complex subqueries. And the fourth one is window functions. And really the goal of the intermediate course is to take you from joining and grouping your tables into being able to dynamically transform them into the final form that you need. We have 2 questions also asking what package is available in R and Python for SQL Server. Yes, in both R and Python, there are packages for accessing data in SQL Server. I don't remember the name off the top of my head. I simply encourage you to look up on Google connecting to SQL Server database in R or Python. That will usually pull up a nice comprehensive guide as to how to get the information you need and access the database. Any recommendations for those of us with MySQL or any of these packages work well with MySQL? I believe there are separate packages in both R and Python for working with MySQL. I encourage you to do the same thing as well, to also look up R and Python as it relates to just using connect to MySQL using R or Python. Okay, so we got another question. How can you include a created column in a subquery into the original selected output? For example, including the total goals in your selected output. So I am going to actually go back on my slides to show you the slide for that, if you'll bear with me for a second. So that was this column. So this is what's called a created column. It's like if you create a new column in Spreadsheets where you add data from 2 of them together, you can select that into the main query. All you need to do is add another comma and put the name of that alias. Because in essence, this has been created as a table before these are run at all. So you can use any of the aliases that you've created in a subquery or an interim table in the main query. So yeah, if I wanted to select total goals, I can just do that as if it's a normal column in my actual database. Okay. So just to be clear, this is another question. So just to be clear, joins are the VLOOKUPs of SQL. Yes, but they're more robust than VLOOKUPs. In essence, a VLOOKUP is a specific type of join called a left join. There are many different types of joins and methods for joining and combining data within SQL. So I encourage you to check out the Joining Data in SQL course that we have available, since that very comprehensively goes through the different ways in which you can combine information from tables. I was asked, are there courses you offer in R and Python? Me personally, no. DataCamp has a wonderful library of both R and Python courses taught by instructors who work with us, as well as instructors who work as data scientists in a variety of different areas. I encourage you to check them all out. We put a lot of work into making sure that our courses are of the best possible quality. So whatever check out our course library. And I encourage you to check out and try out any course in R and Python that interests you. Someone else said, I'm a 100% Excel user using pivots and VLOOKUPs. What's my next step? I think the next step for you is either determining whether or not it's worth setting up your own relational database locally, which has its severe limitations as because you'd be the only one who'd be able to access it on your computer. I would check with your organization's database administrators, IT department, see what exists already in terms of a relational database and a server, like database servers and stuff that have been set up. Like what data is available to you through an existing relational database, and then how can you access it to query it and then get information you need. I would say that's your next step, is to find out where the source of data is before it's being put into an Excel sheet and given to you to work with. I also have a question that says, are case statements similar to if statements or IIF? Yes and no. I haven't actually worked with the double IF statement, but I believe that they're pretty analogous to a normal if statement. Okay. So one other person asked, will the online query formatting portal/tool be vulnerable to the security of the data? And the answer is, I don't know. I would look into it. If you can't guarantee the security of the data around your query, it may be worth manually formatting your subquery or formatting a query that you've received if it's messy. I've certainly spent time doing that working within government work where I've had to manually format and edit stuff that I couldn't send to an external source like this. It may take a bit of time, but in the end, it really is worth it to then save copies of these queries in ways that future users can go back and understand what was done. What is your opinion of Microsoft Access to work with databases? What advantages and disadvantages do you see in its use? So the main disadvantage is that Microsoft is away from it. They're starting to promote their cloud platform, Azure, so there's a good chance that Microsoft Access will stop being supported in the coming years. It also, I think it's a great way to test and work with relational databases locally, though personally I would recommend SQLite over Microsoft Access, but that's a personal preference. I personally find the SQL query to be a little easier to use. They also have a manual query editor where you can drag and drop columns and stuff. But again, it's a matter of preference. If you happen to work with an organization that uses Microsoft Access, it does make sense. Like there is a lot to be learned from working with data in these systems. If our company uses SPSS, is there a way for me to play with our data SQL somehow for free or cheap to be able to see if SQL would be better than SPSS? So my short answer is yes, it probably is better. SPSS has even small in terms of data sizes, like SPSS starts lagging after like 2,000 to 5,000 records. It becomes very difficult to actually process information. It becomes very slow. So a free way to work with SQL and to play around with it is I would look up SQLite Studio. You can also look up working with Postgres data because Postgres is open source. SQLite is so SQLite Studio or PG-admin 4 would be good places to start in terms of downloading something locally, creating a database, manipulating to best suit your needs, either in lieu of SPSS or in addition to it. I have another question here. Is there any limit on the case statement we provide? I would say no. There are no particular limits around the setup data, more complex logical condition. Say if you want to count data where there's full-time jobs and it's at a specific agency, and it was posted in the last month, you can create very complex case statements to test a lot of conditions and then return either whatever value or account that meets that condition. So limits, no. So we are just about out of time. I wanted to say thank you very much for all your questions. We couldn't get to them all, but I really appreciate your time being here. I hope this was helpful to your workflow. Please feel free to reach out to me either on Twitter or LinkedIn, and I'm happy to discuss this further with anyone who's interested. Again, thank you for your time.